Alright, what you see here are parts for a Ford 9-inch center section that I'll be putting together to use in my 69 Mustang. The main reason for this is that I have a 325 gears with 28 spline axles and a traction lock, and I wanted to go to a lower gear, so I got 389 gears here, and also wanted to change to 31 spline axles, going from 28 to 31. So this differential will take 31 spline axles. The case, this is a Ford racing case that Ford designed for use in NASCAR. I purchased this about a year ago. It's a steel case, and I believe it's no longer made, but Ford claims that it's twice as strong as a iron case, and I think they're referring to their nodular iron SVO cases that they used to sell. I'm sure there are aftermarket cases that are have extra material everywhere that are stronger, but this case should be more than strong enough for my needs. The gear set is rim polished. You can see the Pinion gear says GM Racing on it. And so the gears have been made lighter. You can see the material that's been removed right there. There's also scallops on the back side. If you compare that to a Ford gear, which I have here, you can see the difference on the back side there. And there's very little wear on this gear. It almost looks like chrome. You can see the contact points on the gear marking paint. And the Pinion is also had material removed to make it lighter. You can see top and bottom, it's about a 1/4 inch shorter top and bottom compared to a stock Ford gear. On the Ford gear, the very top and bottom, I don't know if you can see the wear pattern, but it's not actually making contact here or way up top, so the overall dimensions of the gear are the same. And the differential, this is a Detroit locker made by G-Force. And both of these, the differential, the Detroit locker, and the ring and pinion are NASCAR used parts. I purchased these from a seller on eBay. If you just search for NASCAR and Ford 9-inch on eBay or Facebook Marketplace, you'll see plenty of used parts with very little wear on them. The differential here has a 2-inch journal diameter. So you need to run this in a case that has 3 1/4 inch race diameter for the races, for the bearings for this differential. And this Ford case has 3 1/4 inch diameter bearing size. So this is the diameter I'm referring to, where the races for the carrier bearings go, 3 1/4 inches. Is the OD. A production Ford case, I believe, is like 3.06, and some of them were actually like 2.89, I believe. I could be wrong on those dimensions. You can also see that it's made by Strange. I think that's about it. Here's the box the gear set came in. You can see it's made by Gleason, GM Racing, 389. And so let's get started. The first thing I did was to remove the bearings from the differential. I thought about reusing the bearings, but they had a little bit of surface rust, so I decided to buy new bearings. And I picked up this clamshell bearing puller, which took them off pretty easily. Initially, I had attempted to use a bearing splitter that I got as a loaner tool from AutoZone, but it didn't seem to be able to do the job. The end started flexing before the bearing started to move, and I thought it might break, so I backed off and returned it and got this clamshell bearing puller. And when I got the bearings off, I could tell that they had been glued on with either epoxy or Loctite, and that's probably why the bearing splitter wouldn't work. But yeah, the clamshell bearing puller did the job. The next thing I did was to replace the springs in my Detroit locker with lighter springs to make it easier to unlock going around turns. And here's just a short clip. If you want to see the full video, I made a separate video, so go watch that. Here are the carrier bearings for the differential. First thing I'm going to do is put the bearings in the oven and the differential in the freezer, and I'm going to try to drive these bearings on without using a press. Okay, so I'm getting ready to put the ring gear on the differential. I've got ARP bolts here. Part number is that. It tells you to use Loctite 242, which is the blue stuff, and to torque to 85 foot-pounds. The bolt size, they're 5/8 inch heads, 5/8 12-point socket. They're 950.950 inches long. Bolt size is 7/16 diameter, 20 threads per inch. And first I'm going to just snug the ring gear down with these 4 bolts, and then I'll go back and do the torque sequence with the Loctite. I can get these holes lined up and get some bolts started. Alright, so it feels to be on, snugged up all the way. Time to put the bearing on the pinion, the bottom bearing. bottom bearing is the large one. The one that goes on top of, on the outside of the pinion support is the smaller one. And the bearing number is Timken HM 89443. And I'm going to do the old bearing in the oven, pinion in the freezer trick, see how that works. Here is the smoking hot pinion bearing. Look at that. No fuss. Right on there. Alright, so as you can maybe guess, I am in the process of trying to set my pinion bearing preload. I've got a solid spacer set up here. Pinion support, pinion bearing, yoke, top pinion bearing, pinion nut. And so for the pinion spacer, it's got two halves. Shims go in the middle to adjust the thickness. This will be my third attempt. The first two attempts, well, the last attempt was a little bit too tight, 22 inch-pounds. I'm looking for a spec of between 15 and 20 inch-pounds of drag on the bearings. And I'm going by the specs on the Strange website because it's where I got most of my parts. And so the first attempt I had 2 shims in the spacer setup, and thickness was about 465 thousandths. And when I assembled this setup, it at around 50 foot-pounds, I just stopped to check the pinion support to see if it spun, and it was completely frozen, which tells me that my pinion spacer setup was not thick enough, that it was bottoming out on the bearings. So tried again, went to 4 spacers or 4 shims, and my thickness was around 487 thousandths, I believe. Torqued it down to 150 pound-feet. That should be sufficiently tight to compress everything. And like I said, the resistance was 22 inch-pounds of drag. And so this time I've played with the shims. I'm still using 4 shims, and the thickness is now around 489 thousandths, or 0.4885 to be precise. So basically assembles like this. Put your spacers in, or put your shims in middle of the spacer. Put your spacer setup on the pinion. Should slide right down. Pinion support goes on, just gently drop it down. Then the top bearing goes on. Gonna drive that down with this aluminum tube. After that, I'll put the yoke on, put the pinion nut on, torque it down, and yeah, I'll try with an inch-pound torque wrench to measure the resistance. So in a minute, I'll show you what it is. Alright, so let's see what it is. Kind of using a cheap inch-pound torque wrench. It looks to be between 10 and 20, closer to 20, so I'd just call that maybe 18 or so. I think I'm good. Okay, so what you see here with this crazy setup is I'm getting ready to take the pinion assembly back out, and I'm doing that to put an oil slinger on, as well as put the pinion seal on. And I'm also going to swap the yoke. I intended to put a 1350 style yoke on here from the beginning, but actually this was on my car, so I had to get under the car and take it off, and now I'm going to swap and put this yoke on. And so these tools, I got this pinion adjusting wrench, the spanner wrench here for the carrier bearings, as well as this horseshoe shaped fixture that the case can be bolted to, and basically acts as a rotisserie. It can mount in an engine stand, or you can bolt it to your workbench. And I can also clamp it in my vise, but I'm not sure if I'm going to use this or not. Anyway, I got these three tools from Speedway Motors. And let's see if I can get this thing off of here. So as you can see, I've got the pinion nut off. I was able to break it loose with the setup I just showed. And one thing that you'll probably need to do is use a puller to remove your yoke. But in my case, this yoke comes off rather easily. The splines, the fit between the splines on the yoke and the pinion is rather loose, or it's not a press fit, I'll say that. This yoke is a 1310 yoke made by Curry. Maybe that's how you say it. The other yoke I have, this 1350, also goes on and off easily. So the oil slinger just goes on like that. The pinion seal goes like that, and I'm going to use this piece of fiberglass tube about 2.5 inches in diameter that I just happen to have sitting around to drive on the pinion seal. So I'm going to stand it up vertically and drive on the seal, and you'll see it back in a minute. Oil slinger, seal, put some grease on the seal so it doesn't start up dry. I'm getting ready to tighten the pinion nut down to spec, but before I do so, I'm going to put some RTV along the splines on the top of the yoke to seal it so oil doesn't come back through. And then I'm going to put some blue Loctite on this pinion nut. This isn't your typical pinion nut that you would get with an install kit that already has sealant on it. This is another used NASCAR part, ARP 12-point pinion nut. So I'm going to put some Loctite on and some RTV on, and I'll be back in a second. Okay, I don't know if you can see that, but I took a bead of RTV and then smeared it around with my finger. I took the yoke off to do that and then put it back on. And here's the pinion nut. As you can see, I have snugged the pinion nut down. I'm going to wipe off the blue Loctite there. And I'm going to install the tool that I used earlier to hold the pinion yoke, and so I can get 175 foot-pounds of torque is the spec I'm going for. So be right back. All right, so this is the setup I'm using to try to torque this pinion nut to spec. I've got this bar here that I used earlier that's threaded into the yoke to keep the yoke from moving, and the torque wrench is set to 175 foot-pounds. So we'll see if I can actually torque this thing to 175. And there it is, 175 foot-pounds. And for reference, the spec I'm using comes from this Chilton's manual from 1972. American cars from 65 to 72. And there's your diagram of the Ford rear. And the spec, come down here to number 30. Tighten the pinion shaft nut to a max of 175 while tightening, and so on. So there you go. I think we're good. Depending on which spec you read, it may vary a little bit, but 175 foot-pounds, I do not think this is going to back off. So going to proceed to the next step. All right, before I move on with the rest of the build, I'd like to just point out a couple things. I have painted the pinion support housing and the yoke. They were bare cast iron. I've painted them with cast iron colored paint. It is this VHT engine enamel. So I just did that for corrosion protection, and it actually looks about the same color as the paint on the housing here, which looks like it's I mean, no, it's steel. It is a steel housing, but it looks like they've applied a cast iron type finish to it. As you can see here, there's a machine surface that doesn't have paint on it, where there's a provision for a diff cooler. If you want to run one, that's where it would go. So I'll probably hit that with some paint. The pinion support housing is a Daytona pinion support. It's made by Strange. So the Daytona just has a larger outer bearing to take more of a load. But I think that's all for the pinion support, and we'll move on to flip the case over and put the differential in. All right, after having torqued the pinion nut, I figured I would try and see how much additional drag this bearing has picked up, or how much additional preload there is with the seal in place. I guess the preload will be the same. It's just going to take more torque to turn this. So it'll give a higher indication, and it looks like we're at about 22 to 24 inch-pounds. Before it was reading around 18 inch-pounds to turn that. So I think that's to be expected. Here I'll show you the completed pinion assembly. Time to put the pilot bearing, the pinion pilot bearing right there. Time to put that inside the case, the pilot bearing housing. I'm going to first grease the bearings, and then place them in the housing, and then drive them in with the seal driver. All right, I didn't show that, but it went in there pretty straightforward. And time to put the, I don't know what you call this star washer in. I'm going to drive that in also with a seal driver. And there's what that looks like. And I've put the pinion in temporarily, and seems to be in agreement with the pilot bearing. So we'll take that back out. And you can see the grease there where it was riding on the bearing. About halfway through putting this differential together, I picked up a Ford shop manual on a USB stick, and I got this from CJ Pony Parts for about $30. If you're working on an old Ford, I found this pretty useful, so you might want to pick one up. And this is a printout from some of the specs for differential assembly, and I wanted to go back to the pinion bearing preload and the spec for drag on the bearing. And so the spec from the shop manual is 22 to 32 inch-pounds for 8, 8.5, 8 3/4, 9 inch, and footnote of number 2, which is with an oil seal. So the last time I measured with the oil seal, I was right around 22 inch-pounds, maybe a little bit higher. So I am in spec there, maybe at the low end of the spec, but still in spec. I'm in the process of putting the ring gear bolts in. I took them all back out. I had not torqued them to spec, so now I'm putting blue Loctite on them, putting Ultra Torque assembly lube underneath the bolt heads. These are ARP ring gear bolts, and they call for 85 foot-pounds of torque with blue Loctite and Ultra Torque assembly lube underneath the heads. So that's what I'm going to do, and so I put several of them in already. And to get the torque spec, 85 foot-pounds, I'm going to put this back in the case, and I'm going to hold the yoke with the black bar that I showed earlier while I use the torque wrench on the bolts. I haven't figured out another method to do that, to be able to torque these without using a press to hold the differential. So I don't have a press right here, so that's what I'm going to try to do. I think that will work. And so the torque spec on a grade 8 bolt, I'm assuming this is Ford specs from the Ford shop manual for a 69 Mustang. So the normal spec for torque would be 65 to 80 foot-pounds. Yeah, so I'll be back in a minute. All right, so I'm going to drop this differential into the carrier. I've got the bearing races on the sides. Just going to drop it down in like that. And then I'm going to put the caps on. These are specific to each side, so you shouldn't swap them from side to side, and they're marked. The side here has one punch mark, and the other bearing cap has 2 dots. So you can see on the case, if I were to turn this around, there's 1 dot. 1 dot right there, 2 dots on the case on this side. And I'm going to put the caps on first, and then I'm going to put the adjusters on. I think most people put the adjusters on first, but I don't like to do that because I feel like the cap, when you tighten it down, if the adjuster's already in there, you might come down crooked on the threads and mess up the threads. So it's easier for me to just thread these in after the caps are on. That way, if the adjuster doesn't want to thread in, then you know you've got your cap not on squarely. I'll torque these to spec later. And this side goes towards the bearing. You can see they thread in pretty easily, indicating I've got them on. They get a little bit tighter, I guess, but this one's a little bit harder to thread. right, looks pretty good. We'll put the pinion in. All right, I'm getting ready to put the pinion assembly in the case, and I've got these pre-measured, or I've got two shims I've already measured. They're 14 thousandths in thickness, and I think that's a good starting point because the last time I worked on the differential that's in my car, I put a solid spacer in, and that's ended up being the thickness that it wanted. So just for a starting point, I think that's good. And so you want to line up this point here on the assembly with this point on the case, because these bolts aren't all equally spaced. So we're gonna make a mess of these shims. If I had this thing sitting upright, it would probably be better. There we go. I think the first time that end of the pinion was not in the pilot bearing. All right, so I'm gonna put that bar on the yoke and try to torque these, put the rest of the bolts in, and then try to torque the ring gear bolts to spec. All right, so I've got this bar on the yoke, and I'm gonna torque these one at a time. Let's see how this goes. See, that bar should go in. See if I can get this thing to click. There we go, there's one down, 9 to go. So I'm gonna try to do this in somewhat of a crisscross pattern, so I'll mark that one that it's torqued and spin it around. Do one on the opposite side, come back in a minute. Alright, I'm getting ready to set the backlash on the ring gear. Then I'm going to set the carrier bearing preload, and I'm following the steps in the Ford shop manual for a 69 Mustang that you see here. So I am on this step right here, backlash and differential bearing preload, adjustments, all axles. Come down here, remove adjusting nut locks, loosen the differential bearing cap bolts. I don't have the adjustment nut locks on there yet, and I've already loosened these bolts. And then it says for a removable carrier type, tighten, torque the bolts to 20 foot-pounds. So I will torque these bolts to 20 foot-pounds in a second. And then it refers to the adjusters, the left side adjuster and the right side adjuster. The left side is the side on the nearest the ring gear. The right side is the opposite side. And it tells you to loosen the right side nut until it's away from the cup. Tighten the left nut until it's forced into the pinion so that you have 0 backlash. So that's what I'm going to do right now. Loosening the right side nut. And then should be able to tighten this to force the ring gear into the pinion until there is no backlash, which is what I have right now. And it says to rotate the ring gear to make sure no binding's evident. So there we have free rotation, no backlash, and going to move on to the next step. All right, moving on to the next step in the manual. It has you set the bearing preload, the carrier bearing preload, and the backlash simultaneously by adjusting this right side adjuster nut and measuring the amount of deflection on the bearing caps, basically what they call case spread, using a dial indicator with this bridge, which I don't have. So I have set it up like this with a dial indicator on each bearing cap, zeroed them out. So as I tighten the right side adjuster nut, it will, cause these bearing caps to deflect. I will add up the amount on each dial indicator to measure the case spread. It says tighten the right nut until first contacts the bearing cup. I've already done that. Then preload the bearings from 8 to 12 thousandths inch case spread. Rotate the pinion, check for binding. All right. Then it has you loosen everything up and I guess set up the positioning on these so you can put the retaining clips in. So I'm going to skip that step for now. And then it has you do it all over again. Set the case spread to 8 to 12 thousandths inch for new bearings, 3 to 5 for original bearings. On removable carrier type axles, preload is 8 to 12. I think I just said that. New bearings, 5 to 8 for original. As preload is applied, and this is key right here, as preload is applied from the right side, the ring gear is forced away from the pinion and usually results in the correct backlash. So if you're setting a case spread of 8 to 12, it's going to set a backlash. That's for new bearings. It's going to set a backlash of 8 to 12 is what they're saying. So you come over here to the specs. Differential bearing preload, case spread across differential, new bearings, 8 to 12 thousandths, and backlash between ring and pinion teeth is 8 to 12 thousandths. And the only thing I'm not sure of is because this shop manual was written for a stock differential case, and I have an aftermarket case, this Ford Racing steel case, which has probably thicker bearing caps that are made of steel, so I'm not sure I'm going to get the same amount of case spread for tightening the adjuster nut, but I'm going to try and see what happens. All right, so I think I turned that about one hole on the adjuster nut, and I got a little bit over half a thousandths on that side, and that side hasn't budged. So I'm going to pause the camera and tighten this up because it's kind of hard to hold the camera while I'm tightening, and I'll show the results in a minute. All right, so I've gone 2 notches on the adjuster nut, and I've got, so the scale on this is half of what the other dial indicator is, but anyway, I've got, so each mark on there is half a thousand, so I've got 2 thousandths on the right side, and I've got, I think, 2 thousandths on the left side as well. So I'm going to keep going. All right, so I've, the spanner wrench that I have, this purple wrench, is getting kind of hard to turn, so this pinion yoke tool actually has little detents on here for using on the adjuster nuts as well, so you can get a lot more torque on that, so I'm going to use that now. All right, so I have turned the right adjuster nut 1, 2, 3, 4, and a little bit more, and I have 5 on this side and about 3 on that side, so that is 8, and I'm going to stop tightening the right nut, and I'm going to measure the backlash. And I will start that in a minute. All right, so as you can see, I have the dial indicator in place. I've been playing with it, rocking it back and forth, so you can probably see what the backlash is already. It's looking like about 8 or 9. Spec is 8 to 12, so I think I'm in spec. I'm going to call it good. Just one important thing to note is that when you set up your dial indicator, make sure it's positioned like this, perpendicular to the tooth, not coming in at an angle. You want it straight on with the face of the tooth. Otherwise, you're not measuring the full length of travel. for getting all of the backlash. And so that's it for the backlash. And the next step is to measure or look at the contact pattern between the ring and pinion. So I'm going to paint the ring gear teeth with gear marking compound. Here is the gear marking compound I'm using. It's yellow. It's a GM brand AC Delco. All right, so here's what it looks like. It's better than I was expecting. Pretty well centered on the coast side, maybe a tad high. You can actually see maybe a slight oval shaped, depending on how the light hits it, and the shadows might be hard to make out, but the drive side looks like that. Centered as well. Side to side, you can see they're centered. So should I take out a couple thousandths to bring the pattern a little bit lower, or do you think it looks good? I think I might just go with that. All right, so I have rotated the gears around a few more times to try to get a better read on the contact pattern. And one thing I noticed pretty much by accident is the paint that I have on these gears that I painted originally has transferred to the pinion gear and then back onto gears that I hadn't painted. And from the paint markings on those gears, I can see where the shape of the paint and where it is. I can get a better indication that my setup, the contact pattern is good, so I don't need to decrease the shim thickness. The original thickness that I put in here was 14,000, so I kind of lucked out. I'm going to go with that. And the only thing I have left to do is add an O-ring to the pinion cartridge assembly here, so I need to take this back out. And the torque on those bolts, pinion retainer to carrier bolts, is 30 to 45 pounds if you're interested. And as far as being able to read the contact pattern, I'm not going to try to explain that because I'm not an expert on that, but I did use what was in this book here, 4 differentials, and pretty much tells you what you need to do if your contact pattern isn't correct, to either add shims or decrease the shims, or to decrease backlash or increase backlash. And this information, everything in this book, I believe is online at DIYFord.com, so I will link that in the description, so if you're interested, go check it out. So I'm going to add the O-ring here and add the adjuster nuts here, and I'll come back in a minute. All right, so I have the pinion assembly out of the case. I've got the O-ring ready to go on. I have applied grease to it, my lube of choice for this video, Cinco Super Lube, and should just slide right into the groove here. Just like that. And let's see, the pinion bolts, pinion support bolt kit, ARP bolt number is right there. So I'll put everything back in and come back in a second. All right, so I did get the pinion assembly back in with the O-ring on. I couldn't force it in by hand. It would stop with a tiny bit of a gap there, so I had to draw it down by tightening the bolts. So I guess that's kind of to be expected. So on to the adjuster nut locks. Okay, for the adjuster nuts, it just so happens that this side lines up perfectly. I don't have to make any adjustments. So I don't know what the torque is on these. I will come back and torque them up some more. I mean, that's pretty tight, actually. Come back and lean on that some more. All right, coming around to the left side, I wasn't as lucky. You can see this hole was just rotated slightly past this hole, and so I'm going to back this off a little bit, turn it counterclockwise. I know I've seen a video where the person assembling says not to do that, to only tighten these, but I don't want to add any more preload or decrease my backlash any, so I'm just going to back this up a smidge. I don't think it's going to hurt anything. All right, so there it is. I think that about wraps it up. All right, so I took the pinion assembly back out because I wanted to check a couple things. I wanted to check I wanted to check the ring gear runout. I measured that with the dial indicator there, and the ring gear runout was 2 thousandths is what I measured. The spec on that is the max here is 3 thousandths. I also torqued these bearing cap bolts to 85 foot-pounds, and the spec on the bearing cap bolts is 70 to 85. And I also wanted to feel what the preload on the ring gear or the carrier bearings felt like, and by spinning the ring gear, you can see it doesn't spin freely. It's got a good amount of resistance on there, but I think that feels pretty good. I'm going to trust the procedure I used with the case spread method. So I think that's all. Once I put the pinion assembly back in, I think I'm done with everything here, and yeah, that's about it. Okay, so the last and final step is to put the assembly in this 2-gallon Lowe's paint bucket. And I got this tip from watching an old AutoRestomod video, and it works pretty well, so thanks for watching. And there you go. If you need to store your 9-inch, that's what you do.